And now in this lecture we will find the value of x using two different methods. In the drawing we have a right triangle, triangle ABC. Actually angle ABC is a right angle equals to 90 degrees. We also know that BD equals to 3 units, DE equals to 4 units, and we also know that angle ABD equals to alpha, and also angle ADE equals to alpha, and angle AEC also equals to alpha. And we want to find out the value of EC, that is actually x. We want to find out the value of x. So we will start with the first method. Before I start to solve the question, I will present a rule that is actually angle bisector theorem. Angle bisector theorem actually, if we have triangle ABC, triangle ABC can be any triangle, and we have angle bisector AD actually angle bisector AD divides angle BAC, divides this angle. Angle bisector BAD divides this angle to angle bisector BAD divides angle BAC, this angle, to two equal parts, to angle theta and to angle theta. Okay, so angle bisector AD divides angle BAC, this angle, to two equal parts. That is to say, this angle equals to theta and this angle also equals to theta. So actually, angle bisector theorem states that an angle bisector divides the side that it eats in a ratio that equal to the ratio of the angle's legs. Okay, so I will read the angle bisector theorem again. Angle bisector theorem states that an angle bisector divides the side that it is in a ratio that equals to the ratio of the angle's legs. So, according to angle bisector theorem, the angle bisector AD divides the side that it is, that is to say, divides the side BC in a ratio. So it divides the angle, the side that it is, that is to say BC, in such a way that BD over the ratio between BD to DC is equal to the ratio between the angle's legs, and the angle's legs are AB and AC. So the ratio between the angle's legs, that is AB over AC, equals to the ratio that angle bisector AD divides the side BC. That is to say, BD over DC equals to AB over AC. Okay, so angle bisector theorem states that the angle bisector AD divides the side that it is, that is to say BC. BC is divided by AD, that is to say BD over DC, in a ratio that it is equal to the ratio between the angle's legs, that is to say to AB by AC. So BD over DC equals to AB over AC. Okay, so actually if we focus on triangle ABE, actually in the right triangle, triangle ABE, AD is angle bisector. Again, in the right triangle, triangle ABE, in the right triangle, triangle ABE, AD is angle bisector. AD is angle bisector. Again, in the right triangle, triangle ABE, AD is angle bisector. Therefore, the angle bisector AD divides the side that it is, that is to say, divides side BD in a ratio, that is to say, BD over DE, in a ratio that equals to the ratio between the angle's legs, that is to say, it will be equal to AB over AE. AB over AE. Okay. But we know that BD equals to 3 units and DE equals to 4 units, so we can substitute BD by 3 and DE by 4. So we will get that AB over AE equals to 3 over 4. Okay? AB over AE equals to 3 over 4. And we will define AB as 3K. So AB will be equal to 3K according to our definition. So we will substitute AB in this equality by 3K in order to find out the value of AE. So we will get that AB equals to 3K according to our definition over AE equals to 3 over 4. Here we will multiply this equality by AE and we will get that 3K equals to 3 over 4 times AE. Here we will multiply this equality by 4 and we will get that 4 times 3K is 12K equals to 3 times AE. Okay, so we actually got this equality that 12K equals to 4 times AE. Here we will divide this equality by 3 in order to get the value of AE. And we will get that AE equals to 12 over 3 is actually equals to 4K. Okay, so we actually found out that AE equals to 4K. So if AB equals to 3K, then AE must be equal to 4K. Okay, so in the next step, we will continue to focus on the right triangle, triangle ABE. And on the right triangle, triangle ABE, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, so in the right triangle, triangle ABE, according to the Pythagorean theorem, AB square plus DE square will be equal to AE square. Okay, according to the Pythagorean theorem, AB square plus DE square equals to AE square. But we have already found out that AB equals to 3K and AE equals to 4K. So we'll substitute AB by 3K. We'll get that AB square equals to 3K square plus DE. What is the size of DE? According to the drawing, DE equals to 3 plus 4. That is to say, DE equals to 7. So DE squared will be equal to 7 squared, that is actually 49. All equals to AE squared. We have already found out that AE equals to 4K, so we substitute AE by 4K. So AE squared will be equal to 4K squared. Okay? So here 3K squared is 9K squared plus 49 equals to 4K. 4K squared is 16K squared. So here we will subtract 9K squared from this equality, and we will get that 49 equals to 16 minus 9 is 7, equals to 7K squared. So here we will divide this equality by 7, and 49 over 7 is 7. So in total we will get that K squared equals to 7. Here we will take a root out of this equality, and we will get that K equals to positive root 7. Why positive root 7? Because of the fact that K actually is the size of the triangle side, so it must be a positive number. So we found out that K equals to root 7 units, and we have already found out that AB equals to 3K and AE equals to 4K. Okay, so actually we can substitute K by root 7. Okay, we know that K equals to root 7, so AB that equals to 3K will be equal to 3 times root 7 and AE that equals to 4K will be equal to 4 times root 7 because K equals to root 7. Okay, so we actually found out the values of AE and the value also of AB. AB equals to 3 times root 7 and AE equals to 4 times root 7. Okay, so we know that this angle is 90 degrees, so triangle ABC is a right triangle. Therefore, tangents 3 alpha will be equal to BC over AB. Okay, tangents 3 alpha equals to BC over AB. What is the value of BC? From the drawing you can see that BC equals to 3 plus 4 plus x. That is to say BC equals to 7 plus x. So we can write here that BC equals to 7 plus x. And we have already found out that AB equals to 3 times root 7. Okay, so in total we found out that tangents 3 alpha equals to 7 plus x over 3 times root 7. So I will write it down. Here we can write that tangents 3 alpha equals to 7 plus x over 3 times root 7. Okay, in the next step we will focus on triangle, the right triangle, triangle ABE. In the right triangle, triangle ABE, we know that tangents 2 alpha equals to BE over AB. Again, in the right triangle ABE, we know that tangents 2 alpha equals to BE over AB. Okay? But what is the value of BE? BE equals to 3 plus 4. That is to say, BE equals to 7. And we have already found out that AB equals to 3 times root 7. So here we got that tangents 2 alpha equals to 7 over 3 times root 7. So I will write it down that the value of tangents 2 alpha is actually equals to 7 over 3 times root 7. In the next step, we will focus on the right triangle, triangle ABD. So, in the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. Again, in the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. But what is the value of AB? AB equals to 3 units. It is given us in the question. And we have already found out that AB equals to 3 times root 7. So in total we got that the value of tangents alpha equals to 3 over 3 times root 7. So I will write it down that the value of tangents alpha is actually 3 over 3 times root 7. So we actually found out that the value of tangents 3 alpha equals to 7 plus 6 over 3 times root 7. The value of tangents 2 alpha equals to 7 over 3 times root 7. And the value of tangents alpha equals to 3 over 3 times root 7. Okay? But we also know that tangents 3 alpha equals to tangents 2 alpha plus alpha, okay? Tangents 3 alpha equals to tangents 2 alpha plus alpha, and we will find out the value of tangents 2 alpha plus alpha according to a trigonometric identity. The trigonometric identity is tangents, the value of tangents A plus B. Actually it equals to tangents A plus tangents B over 1 minus tangents A times tangent B. Okay, so we will use this trigonometric identity in order to find out the value of tangent 2 alpha plus alpha. Okay, it is actually tangent 3 alpha that equals actually to tangent 2 alpha plus alpha, and the value of tangent 2 alpha plus alpha according to this trigonometric identity is actually tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha minus tangent alpha. Okay, so we have this equality that tangent 3 alpha equals to this expression. In the next step, we will substitute tangent 3 alpha by the value of 7 plus x over 3 times root 7. We will substitute tangent 2 alpha by 7 over 3 times root 7, and we will substitute tangent alpha by 3 over 7 times 3 over 3 times root 7. Okay, so we will get that tangent 3 alpha equals to 7 plus x over 3 times root 7. It equals to tangent 2 alpha. We already found out that tangent 2 alpha equals to 7 over 3 times root 7 plus tangent alpha. Tangent alpha equals to 3 over 3 times root 7, all divided by 1 minus tangent 2 alpha times tangent alpha. Tangent 2 alpha equals to 7 over 3 times root 7, and tangent alpha equals to 3 over 3 times root 7. So in total we got this equality. Here we will substitute 1 by 3 times root 7. In order to have common factor of this expression, we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7, okay? And we will get that seven plus x over 3 times root 7 equals to, here 7 plus 3 is 10. 10 over 7 times root 7, 3 times root 7, all divided by, again we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. That is equals to 1. So here we substituted 1 by this expression that equals to 1. In this way we will have common factor with this expression. Here we have 3 times 7 is 21. So we got this equality. Here we will move this expression to the numerator, and we will move this expression to the denominator. Okay, so we will get that 7 plus x over 3 times root 7 equals to 10. 3 times root 7, 3 times root 7 over 3 times root 7, and this expression will be moved to the denominator. It is 3 times root 7, 3 times root 7 minus 21. So here we have 3 times root 7 in the numerator, and we have 3 times root 7 in the denominator. So 3 times root 7 will get cancelled, and what is left after we cancelled 3 times root 7? 7 plus x over 3 times root 7 equals to, here 10 times 3 is 30. In total we will get in the numerator 30 times root 7 over 3 times root 7 times 3 times root 7 minus 21. So in total we got this equality. So actually 7 plus x over 3 times root 7 equals to 30 times root 7, 30 times root 7, and in the denominator we have 3 times 3 is 9, and root 7 times root 7 is 7. So 9 times 7 is 63. So in total this expression equals to 63 minus 21. So in total we got that 7 plus x over 3 times root 7 equals to 30 times root 7 over 63 minus 21. Here 63 minus 21 is 42, so I write it down. So here we will multiply this equality by 3 times root 7, and we will get that 7 plus x equals to 30 times root 7, 7 root 7 times 3 over 32. So here here 3 times 30 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630. So we got that 7 plus x equals to 630 over 42. And 630 over 42 equals to 15. So we will get that 7 plus x equals to 15. Here we will subtract from this equality 7, and we will get that x equals to 15 minus 7 equals to 8 units. Okay, so we found out that the value of x is 8 units, that is to say EC that equals to x equals to 8 units. Okay, so we finished with the first method. So we will find out the size of EC that equals to x according to the second method. Actually, in the second method, we will do a construction. We will extend BD by 3 units. Okay, we will extend BD by 3 units. And we'll define this point as point M. Then we will join together points M and A by a straight line. What is the size of this angle? Actually, we have the rule that the sum of the angles on a straight line equals to 180 degrees, and we know that MD is a straight line. MD is a straight line, therefore the sum of the angles in the straight line MD equals to 180 degrees, and especially the sum of the angles on a straight line MD, on the straight line MD at point B must be equal to 180 degrees. Therefore, here we have what are the angles at point B. We have this angle that equals to 90 degrees. So 90 degrees plus the size of this angle, that is actually angle ABD, must be equal to 180 degrees. Okay, 90 degrees plus the size of angle ABD must be equal to 180 degrees according to the rule that the sum of the angles on a straight line equals to 180 degrees. Okay, we write it down. The sum of the angles on a straight line is equal to 180 degrees. Okay, the sum of the angles on a straight line equals to 180 degrees. So the sum of the angles on the straight line MD at point B must be equal to 180 degrees. That is to say 90 degrees plus the size of angle ABD must be equal to 180 degrees. Here we will subtract from this equality 90 degrees, and we will get that the size of angle ABD is actually equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle ABD is a right angle. Angle ABD is a right angle. So in the next step, we will prove that those two triangles, those two right triangles, are congruent to each other. So we will focus on the right triangle, triangle AMD. And on the right triangle, triangle ABD. Okay, so we will focus on triangles AMD and ABD. So on those two triangles, we actually extended side BD by 3 units. So therefore MB equals to also to 3 units because we extended BD by 3 units. So that is to say MB equals to 3 units. Therefore MB equals to BD equals to 3 units. MB equals to BD equals to 3 units. Okay, MB equals to 3 units because we built it like that. Okay, we extended BD by 3 units, so MB equals to 3 units according to our construction. So MB equals to BD, that equals to 3 units. Then we know that angle ABM equals to angle ABD, and both those two angles are right angles. So angle ABM is equal to angle ABD, and both those two angles are right angles. They are equal to 90 degrees. Okay, angle ABM equals to angle ABD equals to 90 degrees, and also AB is a common side, so AB equals to AB, AB equals to AB. AB actually belongs to both triangles. It is a common side. Okay, AB equals to AD. So we actually proved that the right triangle AMD is congruent to the right triangle ABD according to side angle side rule. Okay, we actually proved that those two sides and the angle between them in this triangle, triangle AMB, are equal to those two sides and the angle between them in triangle ABD. Therefore, we proved that those two triangles congruent to each other according to side angle side rule. Okay, so I write it down. So actually triangle, right triangle AMD right triangle AMD congruent, that is the sign of congruent, to right triangle ABD. Okay, right triangle AMD congruent to right triangle ABD according to side angle side rule. What is side angle side rule? It actually, if you prove that two sides and the angle between those two sides in one triangle are equal to two sides and the angle between those two sides in the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. And we proved that in the right triangle ABD, those two sides, side AB and side MB, and the angle between them are equal to those two sides and the angle between them in triangle ABD. Therefore, we proved that those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. That is to say, angle MAB is equal to angle BAD okay, angle MAB equals to angle BAD, but angle BAD equals to alpha. Okay, angle BAD equals to alpha, therefore angle AMB also will be equal to alpha. Again, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. I will write it down. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So, I will read the rule again. The rule states the corresponding angles in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore the corresponding angles will be also equal to each other according to the rule that is stated, that corresponding angles in congruent triangles are equal to each other. And from the fact that those two triangles can go into each other, we can conclude that AM equals to AD, AM, side AM in triangle AMB equals to side AD in triangle ABD. Okay, AM equals to AD, and those two sides are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Corresponding sides in congruent triangles are equal to each other. Again, AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Actually, those two triangles congruent to each other, therefore the corresponding sides, that is to say AM and AD, will be also equal to each other, that's all. Okay, so if we define AM as Y, then AD will be also equal to Y because of the fact that those two sides are equal to each other. Okay, so AM equals to AD equals to Y. So in the next step we will focus on triangle ADC. And on triangle ADC, actually in triangle ADC, we know that AE is angle bisector. Again, in triangle ADC, AE is angle bisector. Again, in triangle ADC, AE is angle bisector. Why AE is angle bisector? AE is angle bisector because of the fact that it divides angle DAC, this angle, it divides this angle to two equal parts, to alpha and alpha. Therefore, AE is angle bisector in triangle ADC. And we have the rule, the angle bisector theorem. According to angle bisector theorem, the angle bisector AE divides the side that it eats in a ratio, that is to say DE over EC, in a ratio that equals to the ratio of the angle's legs, and the angle's legs is AD and AC, so it is AD over AC. So according to angle bisector theorem, DE over EC equals to AD over AC. Okay? And what is the size of DE? The size of DE is 4. What is the size of EC? EC equals to X. What is the size of AD? The size of AD is actually Y over AC. So in total we got that 4 over X equals to Y over AC. Here we will multiply this equality by X, and we will get that 4 equals to YX over AC. Here we will multiply this equality by AC, and we will get that 4 times AC equals to YX. We will divide this equality by 4 in order to get the value of AC, and we will get that AC equals to YX over 4. That will be our first equation. We found out that AC equals to YX over 4. Okay? So in the next step, we will focus on triangle AMC. On the big triangle, triangle AMC. So in triangle AMC, actually AD is angle bisector. Again, in triangle AMC, the big triangle, AD is angle bisector. AD is angle bisector. Again, in the big triangle, triangle AMC, AD is angle bisector. Why AD is angle bisector? AD divides angle CAM to two equal parts. That is to say, the first part is 2 alpha. This equals to 2 alpha. And the second part is also 2 alpha. So the angle bisector AD divides angle AMC to two equal parts, to 2 alpha and 2 alpha. Therefore, AD is angle bisector in triangle AMC. And according to the angle bisector theorem, we know that the angle bisector divides the side that it hits, that is to say MD over DC, in a ratio that equals to the ratio of the angle legs. What is the angle legs? Is AM and AC. So AM over AC. So the ratio between the legs of the angle, that is to say AM over AC, will be equal to the ratio that angle bisector AD divides side MC. And the ratio that angle bisector AD divides side MC is the ratio of MD over DC. Okay, so in total, we will get that MD over DC equals to AM over AC. Okay? But what is the value of MD? MD equals to 3 plus 3, 6. 3 plus 3 is 6. So MD equals to 6. What is the value of DC? DC equals to 4 plus X. DC equals to 4 plus X. All equals to AM. What is the value of AM? AM equals to Y according to our definition over AC. So in total, we got that 6 over 4 plus X equals to Y over AC. Here we will multiply this equality by AC, and we will get that we will multiply equation number 2 by AC, and we will get that AC times 6 over 4 plus X equals to Y. Here we will multiply this equality by 4 plus X. So 6 times AC will be equal to Y times 4 plus X So we got this equality, equation number 2. Here we will divide this equality by 6 in order to get the value of AC. We will get that AC, according to equation number 2, equals to y times 4 plus x over 6. Okay, but we have already found out in equation number 1 that AC equals to y times x over 4. Okay, so we have the values of the value of AC in those two equations. So we will create equation number 3 that states that AC equals to AC, and we will substitute the value of AC by the value of AC from equation number 1 on this side of the equality, and we will substitute AC on the other side of the equality by the value of AC in equation number 2. So, okay, so we will get that AC from equation number 1 is actually y times x over 4, and AC in equation number 2 is y times 4 plus x over 6. So here we can divide this equality by y. Why we can divide this equality by y? Because y is the size of this triangle side, and the size of triangle side must be a positive number. It can never be 0. That is the reason that we can divide the equation number 3 by y, because y can never be 0 as the side of a triangle. It must be a positive number. So we will divide equation number 3, this equation, by y, and we will get that x over 4 equals to 4 plus x over 6. Okay, so we got here that x over 4 equals to 4 plus x over 6. Here we will cross multiply this by 4, and then we will multiply this equality by 6. We will get that 6x equals to 4 times 4 plus x. So here we will open the brackets in this side of the equality, and we will get that 6x equals to 16 plus 4x. So here we will subtract from this equality 4x, and we will get that 6x minus 4x is 2x equals to 16. Here we will divide this equality by 2, and we will get that x equals to 8 units. X equals to 8 units. So we found again that the value of x is 8 units. Okay, here x that equals to EC equals to 8 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the value of x. We know that those angles are equal to each other. They are all equal to alpha. And we also know that MB equals to 3 units, BD equals also BD equals to 3 units, DE equals to 4 units. And we also know that angle ABD is a right angle, it equals to 90 degrees. And we want to find out the value of x, that is also EC. Okay. So in order to solve this question, we actually used in both methods the angle bisector theorem. The angle bisector theorem states that an angle bisector divides the side that it is in a ratio that equal to the ratio of the angle's side, of the angle's legs. So, according to angle bisector theorem, the angle bisector AD that bisects angle BAC, or in other words, it divides angle BAC to two equal parts, actually creates the following relationship between the angles side. So it actually divides angle BC in a ratio, that is to say BD over DC, that equals to the ratio of the angle's legs, and the angle's legs are AB and AC. So the ratio between the angle's legs, that is AB over AC, equals to the ratio that AD divides BC, and AD divides BC in a ratio of BD over DC. So the ratio that AD divides the side BC, that is to say BD over DC, equals to the ratio between the angle's legs, and the ratio between the angle's legs is AB over AC, or BD over DC, that is the ratio that AD divides side BC, equals to the ratio between the angle's legs, that is to say the ratio between the angle's legs is AB over AC, or AB over AC equals to BD over DC. Okay, again, an angle bisector divides the side that it is in a ratio that equals to the ratio of the angle's legs. Okay, so the ratio between the ratio that AD divides BC, that is to say BD over DC, equals to the ratio of the angle's legs, and the ratio between the angle's legs, this angle's legs, is AB over AC, or AB over AC equals to DC to BC over DC. Again, BD over DC equals to AB over AC, or AB over AC equals to BD over DC. Okay. So we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that AD is angle bisector. Why AD is angle bisector? Because it divides angle BAC to two equal parts. This angle is alpha and this angle is also alpha. It divides angle BAE to two equal angles, alpha and alpha. Therefore, AD is angle bisector on triangle ABE. And according to the rule of angle bisector, BD over DE must be equal to AB over AE. Okay, according to the rule of angle bisector, BD over DE equals to AB over AE. But we know that BD equals to 3 and DE equals to 4. So we substituted BD by 3 and DE by 4. And we got that AB over AE equals to 3 over 4. And then we defined AB as 3K. That is to say AB equals to 3K. After we defined AB as 3K, we found the value of AE by putting the value of AB in this equality. Or we substituted AB by 3K in this equality, and we got that 3K over AE equals to 3 over 4. Here we multiplied this equality by AE, and we found that 3K equals to 3 over 4 times AE. Here we multiplied this equality by 4, and we got that 12K equals to 3 times AE. We divided this equality by 3 in order to get the value of AE. We got that the value of AE equals to 12K over 3 is 4K. So AE equals to 4K, or we can say that if AB equals to 3K, then AE must be equal to 4K. Okay? So AB equals to 3K, and AB equals to 3K, and AE equals to 4K. And then we focused again on the right triangle, triangle ABE. We implemented the Pythagorean theorem that states that the sum of the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. AB square plus DE square equals to AE square. But we have already found out that AB equals to 3K, so we substituted AB by 3K, and DE equals to 3 plus 4, that is to say to 7. So DE equals to 7, so DE square will be equal to 7 squared, that is 49, and AE equals to 4K. We have already found out that AE equals to 4K, so we substituted AE by 4K, and AE square equals to 4K square. Here 3K square equals to 9K square, plus 49 equals to 16K square. We substituted for this equality 9K square, and we found that we got that 49 equals to 7K square. We divided this equality by 7, and we got that K square equals to 7. Then we took a root from this equality, we took out the root from this equality, and we got that K equals to the positive value of root 7. So we have AB that equals to 4K, so we can substitute K by root 7, because K equals to root 7. So AB will be equal to 3 times root 7, and A equals to 4K, and K equals to root 7. So AE will be equal to 4 times root 7. So we found that AB equals to 3 times root 7, and A equals to 4 times root 7. Okay, so in the right triangle, triangle ABC, the big right triangle, triangle ABC, we know that tangent 3 alpha equals to BC over AB. Tangent 3 alpha equals to BC over AB. But what is the value of BC? BC equals to 3 plus 4, that is 7 plus x. So BC equals to 7 plus x, and AB, we have already found out that AB equals to 3 over root 7. So in total we got that tangent 3 alpha equals to 7 plus x over 3 times root 7. Then we focus on the right triangle, triangle ABE. This triangle, you know that in this triangle, tangent 2 alpha equals to BE over AB. Okay, tangent 2 alpha equals to BE over AB. What is the value of BE? BE equals to 3 plus 4. BE equals to 7 units, and we have already found out that AB equals to 3 times root 7. So in total we got that tangent 2 alpha equals to 7 over 3 times root 7. And then we focused on the right triangle, triangle ABD. We know that on the right triangle, triangle ABD, tangent alpha equals to BD over AB. Tangent alpha equals to BD over AB. What is the value of BD? BD equals to 3 units, and AB equals to 3 times root 7. So BD over AB is 3 over 3 times root 7. So we actually found out the values of tangent 3 alpha, tangent 2 alpha, and tangent alpha. Then we also know that tangent 3 alpha equals to tangent plus tangent 3 alpha equals to tangent 2 alpha plus alpha. Okay? Because 3 equals to 2 plus 1. 3 equals to 2 plus 1. So tangent 3 alpha equals to tangent 2 alpha plus alpha. So in order to find out the value of tangent 2 alpha plus alpha, I presented to you a new trigonometric identity for tangents A plus B. Actually, tangents A plus B equals to tangents A plus tangents B over 1 minus tangents A times tangents B. So we used this trigonometric identity in order to find out the value of tangents 2 alpha plus alpha. The value of tangents 2 alpha plus alpha according to this trigonometric identity equals to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. Okay, so here we have this equality, and we actually have already found out the value of tangents 3 alpha. Tangents 3 alpha equals to 7 plus x over 3 times root 7. We have already found out the value of tangents 2 alpha. Tangents 2 alpha equals to 7 over 3 times root 7. And we have already found out the value of tangents alpha. Tangents alpha equals to 3 over 3 times root 7. So we substituted the values of tangents 3 alpha, 2 alpha, and alpha by the values that we have already found out, and we got this equality. Okay, here we have actually one equation with one variable only. We solved this equation, and we found out that the value of x is actually 8 units. We found out that x equals to 8 units, that is to say EC that equals to x equals to 8 units. So that was the first method to find out the value of x. X equals to 8 units according to the first method, and then we found out the value of x according to the second method. Here we actually made a construction. We extended side BD by 3 units, and we defined this point as point M, and then we join together points M and A by a straight line. So we have here new triangle, triangle A and B, and actually this angle must be equal to 90 degrees according to the rule that the sum of the angles on a straight line equals to 180 degrees. So here we know that MD is a straight line. Therefore, the sum of the angles on the straight line MD must be equal to 180 degrees. And if we focus at point B, the sum of the angles on the straight line MD must be equal to 180 degrees. And we know that this angle ABD equals to 90 degrees. So 90 degrees plus the size of angle ABM must be equal to 180 degrees. 90 degrees plus the size of angle ABM. Here it is actually angle ABM. And okay, 90 degrees, this angle equals to 90 degrees plus the size of this angle, that is angle ABM, must be equal to 180 degrees. Okay, according to the rule that the sum of the angles on a straight line equals to 180 degrees. So here we subtracted from this equality 90 degrees and found out that that the size of angle ABM equals to 90 degrees. Okay, we subtracted 90 degrees from this equality and we found out that the size of angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. So we actually found out that this angle is a right angle, that is to say it equals to 90 degrees. Then we actually proved that triangle ABD, the right triangle ABD, is congruent to the right triangle ABM. First of all, we have here two sides that are equal to each other. MB equals to BD equals to 3 units. MB equals to BD equals to 3 units. And we also know that those two angles are equal to each other. They are right angles. They are equal to 90 degrees, both of them. So angle MBA equals to angle ABD equals to 90 degrees. And we also have here a common side, AB equals to AB. AB belongs to both triangles. So AB equals to AB. So we actually proved that triangle ABM is congruent to triangle ABD according to side angle side rule. Okay, triangle AMD congruent to triangle ABD according to side angle side rule. Okay, from the fact that triangle AMD congruent to triangle ABD, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles must be also equal to each other. That is to say, angle MAB equals to angle DAB equals to alpha. We know that angle BAD equals to alpha, so angle AMAD that equals to angle BOD must be also equal to alpha. So angle MAB also equal to alpha. Okay? According to the rule that corresponding angles in congruent triangles are equal to each other. And from the fact that those two triangles congruent to each other, we can conclude that AM equals to AD. AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say AM and AD, must be also equal to each other. Okay, then we focused on triangle DAC. On triangle DAC, we know that AE is angle bisector. Why AE is angle bisector? Because it divides angle DAC, this angle, to two equal angles, to angle alpha and alpha, to two equal parts. Therefore, AE is angle bisector in triangle DAC, and we have the rule of angle bisector that the angle bisector AE divides the side that it is, the side that angle and the side AE that angle bisector AE is side DC. It divides side DC in a ratio, that is to say DE over EC must be equal to the ratio between the angle legs, and the angle legs are AD and AC. Therefore, the ratio that angle bisector AE divides CD is DE over EC, and that ratio equals to the ratio between the angle sides, and the ratio between the angle sides are AD over AC. So we have this equality, and what is the value of DE? DE equals to 4. What is the value of EC? EC equals to X. So here we have DE over EC is 4 over X. What is the value of AD? AD equals to Y according to our definition. So in total we got that 4 over X equals to Y over AC. Here we multiply this equality by AC, and we got that 4 times AC equals to XY, and then we divided, here we multiply this equality by X first of all, and then here we multiply this equality by AC, and we got that 4 times AC equals to YX. Here we divided this equality by 4, and we got that AC, according to equation number 1, equals to Y times X over 4. That is equation number 1. And then we focused on the big triangle AMC. We know that on the big triangle AMC, this triangle AD is angle bisector. Why AD is angle bisector? Because it divides angle MAC to 2 equal parts, so 2 alpha and 2 alpha. Okay, so according to the rule of angle bisector, the angle bisector AD divides side MC in a ratio, that is to say MD over DC must be equal to the ratio between the angle's legs, that is to say to AM over AC, or the ratio that AD divides side MC is MD over DC, and that ratio equals to the ratio between the angle sides, between the angle's legs, that is to say to AM over AC. And what is the value of AD? Of MD? MD equals to 3 plus 3. The value of DC equals to 4 plus X. So MD over DC is 6 over 4 plus X. What is the value of AM? AM equals to Y according to our definition. So in total we got that 6 over 4 plus X equals to Y over AC. Here we multiply this equality by AC. We got this equation. Then we multiplied this equality by 4 plus X, and we got this expression, and then we divided this equality by 6, and we got that AC equals to Y times 4 plus X over 6. This is according to equation number 2. According to equation number 1, AC equals to Y times X over 4. Then we created the equality that states that AC equals to AC, and we substituted AC by the value of AC according to equation number 1 in this side of the equality, and on the other side of the equality we substituted AC by the value that we found for AC in equation number 2, and we got this equality in equation number 3, and we solved this simple equality that is one variable in one equation and found out that the value of x is actually 8 units. So x equals to 8 units according to the second method. The value of AC that equals to x equals to 8 units. Okay, thank you very much.